I want to find the pH of a 0.250 molar NaC2H3O2 solution. So what I need to do is I first need to know, is this a soluble salt? And the answer is yes. Remember, all group 1A's, Na is 1A, are soluble. So if I break that down, that tells me that NaC2H3O2 would look like Na plus C2H3O2. So I know that there is no acidic or basic properties that are associated with the sodium ion. So that means I need to look at the acetate ion over here. So I need to write a reaction starting with that acetate ion. Now remember, it says it's in a solution, so if it's in a solution we know that it is in water, and we know that it is going to be at equilibrium. One of these I have to add an H2 and one I have to take it away from, right? So I'm going to add it to the first one, so that becomes an acid, so HC2H3O2. And if I take it away from water, that becomes the hydroxide ion. And there's a little AQ there, you just can't see it. So what is my initial concentration? Well, my initial is for NaC2H3O2, so that's this first term right here that I see. So that's going to be 0.250. Water doesn't count. And then I have 0 and 0. The change, minus x on the left, plus x on the right. What's the equilibrium? I'm going to add straight down. So I'm going to get 0.250 minus x, x, and x. So what am I going to do with that? Well, we know that this is a base, right, because it made OH. So I'm going to have K sub B, which I know I can find from KW divided by K sub A. I know KW because I've memorized that as 1.0 times 10 to the minus 14th. Ka, I've memorized it, but you can get it off of a table. It's 1.8 times 10 to the minus 5th. When I solve that, I get 5.6 times 10 to the minus 10th. Now I need to do what? I need to set it up like we do everything. K sub B is equal to the products divided by the reactant. So I'm going to say that this is equal to x squared over. I'm going to try to do the approximation because I want my life to be a lot easier. So I'm just going to divide by 0.250. So I need to cross multiply and take the square root, and when I do that I get 1.1832 times 10 to the minus 5 for x. Now how can I make sure that's correct? Remember, I take that number that I just obtained and I'm going to divide by the initial concentration, which we said was 0.250, and then I'm going to multiply by 100, and I got it to be a really small number, 0.0047%. So yes, that's less than 5%, so that means my approximation is okay. That's great, but I haven't found what I want, right? I want to actually find the pH. Well, if this is the concentration of the hydroxide ion, then that would tell me that, what? That pOH equals the negative log of the OH ion concentration. And so when I plug that in, I'm going to have the negative log of that 1.1832 times 10 to the minus 5. I'm going to put that in my handy dandy little calculator, and it's going to spit out 4.92. Remember, you want two significant figures after the decimal when you're dealing with logarithms. Now remember, I don't want pOH, I want pH, so I'm going to have to take 14 minus 4.92, and when I do that I get 9.08.